Hey, welcome back to Made of Wires. We're decompiling Castlevania Symphony of the Night. Trying to get a save checkpoint for the boss fight that we're working on, which is the Ralph Grant Sifa boss fight. Getting juggled really bad here, but that's not ready yet. But we'll get it eventually. I'm gonna pause that so we can get back to what we need to do. If you're not familiar with the Symphony of the Night decompilation project, you can go to certain.z.dev, see what we're working on, and we've been looking at, like I said, the Grant Sifa Ralph boss fight. It's not up in this progress yet, and it's not even, if you go to GitHub, it's not there either. I didn't review changes for this week. Maybe I'll do that tomorrow. I know that was supposed to be my Monday shtick, but I haven't done it yet. Nobody's reviewed this change yet, which is a bummer. That's the thing that speeds up builds considerably. So, well, let's get into it. I didn't do what I said, which was figure out what was going on with the PSP version of this function, which isn't working, but that's fine. There's lots more to do. So let's go find something else to decompile. I'm going to look for... Do I have a clean build here? Let's see. I don't have this in my history. I'm going to look for things that are not decompiled yet. So they'll be in the non-matchings directory. And I like using awk to order these and then sort, and we'll see what we have. So anything that's in a known folder, I'm not going to worry about. Unfortunately, it looks like I haven't done a good job of cleaning my assembly. So let's do this. Let's clean that assembly and extract again, and then we'll get a better idea. Hey, Dizek. Hope everybody had a good weekend. We ate a lot of wings. I ordered too few wings for yesterday. Let's make... There we go. That one's up to date. E-collect still in non-matchings. Oh, but just data. I don't care about that. Let's look for just funcs. There we go. That's a little better. So we have one relatively large function that's kind of off on its own. That might be good to find. So the way that it's ordered on the PlayStation, it's the last function in the overlay, and so it'd be nice to see, I guess, where that coexists with related functions elsewhere. There's some really small things early on, but I think let's take this one. I don't have a good idea yet of where these are. Like I said, I don't have a save point here yet, so I can't run the debugger to break at these different areas. So not sure where these are. Let's create some new scratches. You have to identify this on the PSP still. When so Splat does a great job through SPIM of finding where all the function boundaries are. There's a bunch of telltale signs for MIPS about where function boundaries might be. And this is fun. It's not loading. So pushing things to the stack to start off with, the end of functions almost universally has a jump and return with the RA register function. Hey, Roman. Oh, come on, you can do it. Try to kill a few things and... Oh, there we go. My human check was failing. There's that scene at the beginning of Final Fantasy VII where they're going through the checkpoints on the train. That's what that feels like. Shinra's gonna figure out where I am. Okay, so most likely, I'm always gonna guess, especially based on this, going to Unknown 2C to do a switch. This is probably an entity update function. There's a few other ways we can confirm that, but I'm gonna go with my gut. And we'll get a new decomp. And that's much better. So a few globals that this one's not even being referenced. This one's also not being referenced, so why did they get created? Okay, well that's something. I'd rather have a missing reference, I suppose. Strange. This is likely an array. I'm going to make that an array, and this is this is our standard debug stuff. I'm not even going to worry about the debug stuff because that'll come from a header. And what do we have here? Just some flag. All right. The default, I'm going to assume, is after, and all of these are going to go to block 42. It seems like a good heuristic fit. Could be done. I should get this compiling first, but I can't help myself. Probably. Does it say it looks like a signed 16, unsigned 16, some 16-bit value? Probably. We'll get down there eventually. 29, I screwed something up. I just moved too fast. Or too slow. Not sure. So 50. So we're going backwards. So it looks like this is an optimization. It might not be, but it looks like we're going to be adding, +4 here as we go through. But then we're looking backwards. So I'd rather look forwards. Use var A1, which is also being incremented. So let's do that. So -2 would be the same thing as var A1, 2. -1 would be var A1, 3. Var A1 now has been incremented, so we can go to 0. And we can get rid of var A0 altogether. $156. Oh, so we're going to Scratchpad. So let's see. I mucked with that a bunch a few weeks ago. Let me make sure that I have all those current definitions. I'm just copying this. All right, so it looks like we're treating the first one as a sine 32. So I guess we'll do that. And we'll just say spad 0, right? That's how we use that macro. I'll remember eventually. Looks like it. So spad 0 to 0. These will also eventually use the spad macro, but I'm not worried about that right now. I just want to get to the other unknown. 157. So this is being loaded at, oh, sorry. How about that? Got L value. Now let's try this. Yeah. Just bad parens. No. So we'll say spad 3. It's giving us a pointer. That's better. Okay, 176 and 182. So offset 2 of 008, those are 32 bits or each, so that's going to be 1 0, which is going to be spad 4. And once we get a compiling, we'll see what they all are. Oh, and this gives us a huge hint. 008 is an S vector. I wrote a bunch of macros actually for making these much nicer to read, and I need to probably do that again. So this is a little harder. So we need to cast this as a sine 16. We're going at offset 4, and then to dereference it, we're going to use index 1. Eventually, we'll get this to be an S vector, because that's what it should be, but for now, we'll just do this because it's faster, and that'll get us compiling. I'm a little surprised at how low that is, but that's okay. Oh, we have all the M2C errors. So, for reasons that I don't completely understand, and I've never tried to contribute to the M2C project at all, and so maybe if I would understand the reasoning why. The PlayStation SDK has a few dozen macros related to GTE, which is a custom coprocessor that was built for the PlayStation. And the compiler then has instructions that are specific to that coprocessor, and really these are just copying data to and from that coprocessor, and then the coprocessor does its own thing. So basically you're kind of writing instructions to this other coprocessor, and then there's instructions on your main processor to do that. And those macros are part of the factual information. I'll put it that way. The factual information about the PlayStation architecture. And because they're facts, they're not copyrightable. So, and they're necessary for integration with that system, which also has precedent in copyright law. I don't think there's any danger of really like putting the inverted version of those macros into M2C, but it doesn't have that for reasons I don't know. So eventually we'll go through and we'll go down to 183 here, where all this looks like broken function calls instead of something else. Usually there's M2C error function calls here. But we look for these instructions in those header files, and we can usually tell pretty quickly what they are. If we find the PSP version, those become actual function calls instead of macros, and the PSP makes it super easy to find what those are. So that's what all these are. It was hard before the PSP was as far along as it was. It was relatively hard to find each of those macros. Not anymore. I'm gonna not do that though. Oops, I wanted to unindent, not delete it. I'm gonna go find all the go-to block 20 or 42s, and those are gonna become breaks. Interesting go-to here. My guess is that that's going to be like a step increment. Block 30 and 31, yeah. Let's make that step increment a plus plus. Okay, block 42 is gone. In the SDK stuff, there's some likelihood of go-tos, but I don't know if I've ever seen a legitimate one in the SOTN code. They might be there, I don't know. This weekend I was working on a related project, trying to rewrite one of our utilities from Python into Rust, and it's about binary formats and a lot of other things like that that I find fun but not always easy. And I solved a bug that I was having a lot of issues with. So we're gonna start replacing variables, and then we'll get into the GTE stuff in a second. So I'll probably go through a few examples just to show how they work, and then we'll use the PSP for the rest, because it's kind of boring, honestly. Fun initially, but after that, not so much. Looks like we might have some timers here. Ordering is always going to be an issue here. This is a little interesting. So the first 7 primitives, we do one thing. Probably I as an index instead of having this var A1. I'm not going to worry about that right now. Get rid of the while. Add a while. But then we have this other while loop to do something a little different down here. Compiler usually chooses S2 or I don't know why. That seems to be pretty common. Looks like there might be a switch here. We'll see as we go on. Something like this where if I is less than 0 and then we're checking if I equals 0. That seems like a switch. And then some more checks. Might not be, but it kind of looks like that. I called it a do loop. Thank you, Romy. Like a plus equals for rotate. As always, the greater than equals, if it's an odd number like this, usually that means it's just an equals, or greater than, sorry. I think this is 360 degrees, yeah, in, let me fix this other, in PlayStation. In the PlayStation format. Let's double check it. So this is equivalent to 4096, which is like 1 radian. I thought we had the rot macro for that. No? Maybe I just don't have it in my context. Yeah, I don't have it in my context. A little nicer. Okay, let's look through this and see. Let's actually, I think the next thing I'll do is take a look at some of these and go through how they're found and what to do. So the registers are always fixed that are used for these macros, and so that's usually what I do. So there's arguments to the macros. 0, 1, 2, 3, 4. Sorry, no, those are not the arguments. Those are the instructions that are being passed, and then the values for those instructions or the operands are in the T4 through T6 registers. So we'll look for a CTC T4, and these are inline assembly. And we should have some of these. It looks like maybe I don't. So we'll go to the GTG or GTE headers. And we'll look for T2, T4 is the first one. Let's just open it up. Where's libgte? Oh, yeah, this makes it a little harder. So the registers are given their numeric value, so I'm going to have to go look at what T4 is, what the numeric value of T4 is. But we do have the immediate values here that we can base those off of. And so we're looking at something that's 0, 1, 2, 3, 4. So I'll do that as just a quick scan. CTC2, we'll look for anything followed by comma 0. So here we have 0, 2, 4, which is not what we want. And there are times where we don't have these imported yet. And so maybe we need to go find them. And this may be one of those cases. Let's look for 3. Yeah, I don't see anything. And the same macro is used twice. So let's do this. Let's look at as part of the test data for PsyK, I've we have some of that available to us. Oh, and maybe they're not in libgte. That could be as well. They could be in a different header. So let's try again. CTC2, and I'm going to look for immediate value 3. And it looks like it's in inline C.H, not in the GTE header. Oh, and unfortunately, that is not a macro that I want. Bummer. So it could be, let's go look at the instructions. 172. Oh, I'm looking at the wrong thing. So we do, in the original instruction, the M2C didn't put it in there. This is the correct one. So we get the load word instructions that are in between here. And we should have this set rotation matrix already available to us. I'm going to go back to the one that we have in include the GTE, and we'll use that. This takes one arg, and My guess is it's going to be this matrix that's in the scratch pad. So we'll cast this as a matrix. And this will be at SP0. Screwed something up along the way. Too many friends. Hey, HP Gravity Well, good to have you. How's life? Staying warm, I hope. I don't know if it's cold. Sorry about your team for showing. Same thing here. And then these down here should be a little simpler. The only thing that changes, and we should look again at what those are, but the main thing that changes is which register. So it's always this number 5 operation, and which register that data is coming into or going back to. So let's find those. Should really... And what I want to make sure is, do we have the load words in there? So I see 5. It looks like it might just be this LTD XYZ. That's what it is. And we don't have documentation here. I could go back to the... these are in libref. Maybe libgte.pdf. You can find that at your local archive.org. I think I'm passing in what? There's a... I'm not sure. Maybe -21? No, that... so we don't have that macro. Let me grab those. I did have to, once a long time ago, I was writing some C++, and I wanted to put some, I needed to use a 128-bit intrinsic with, no, there was no intrinsic for a 128-bit value. I wanted a 120-bit compare and swap, which the instruction was available, but there was no... There's a 1 here, too. Looks like the -15 is right. -15 hex. We'll figure out what that is in a second. So one of these is going to be Y, and one of them is going to be Z. And looks like this is 21, and then Z is... This one is 21. This one is 0. That's wrong. We need something with T8, which looks like register 8. I don't see anything with that. Let me grab the MIPS register list. I don't remember offhand what number is what. That's T0. 8 is T0. Oh, so we need T8, so that would be 16. So it looks like I have the wrong instruction. Possibly the wrong macro. Or maybe I have the wrong values. Oh, T8 is actually register 24. I don't see any C2C or CTC2s for that register, so I must be reading this wrong. It says it's going to T8. And according to the internet, which is never wrong, T8 should be numeric value 24. I don't see anything that uses that, though. All right, well, let's keep going and we'll see what we can get to. Let's actually do this. Oh. I had all these wrong, though. Y, Z. Can we correct them? Can I correct them? Actually goes to T3, so these are very wrong. Let's take this opportunity. So we have GTE set rotation matrix. We can use that as a key to go searching for this function on the PSP. And if it doesn't exist, it's a symbol that we can add. So we don't have that. The other thing that's good to search for is sound effect IDs. It's usually pretty unique. And there's only one function that uses this particular sound effect ID. And it's here. And unfortunately, though, we do have a bunch of the GTE macros, but it looks like not. Oh, it's just being called set matrix and rotate matrix. I wonder why. Why aren't we prefixing those? That seems very inconvenient. So let's make a PSP scratch. I wonder why. Somebody tell me. So I just saw your message and you're still trying to get over the last. I'm over on the west side. I lived in Seattle for a while. And so we were pretty much everybody in my family was going for the Seahawks. I don't care for them normally, but in this case it was who seemed the better of the two teams, and they were. And I was kind of hoping for a shutout, just for the history of it all, but that didn't happen. For any Europeans that are watching the Super Bowl, which is the World Championship of football, the real football, happened over the weekend. Time to watch commercials and eat chicken wings. They're also known as buffalo wings. And we know that buffaloes have no wings. And we don't care. So this gives us a little bit more insight as to what those macros were. We have them all named, which is nice. So I'm going to copy over some of that, and then we'll rely on the layout of the PlayStation version. I'm just going to grab those symbols, though. Different than I expected. I always make a bunch of junk food for the Super Bowl and have a lot of fun with that. I'm also going to grab all of these macros. We're going to have to interpret some of the scratch pad stuff. So this is going to be the same as S-Pad 1. And we need to know what var S3 was. After set transformation matrix. I'm not quite sure. It's like a global. I'm going to comment those out for now, and we'll come back to what they might have been. Oh, not in the PSP one though, in the PlayStation one, because we don't have that. We don't have that variable, and the offsets look fine, but we need to figure out where S3 came from, which is one of those variables that was in the original decompilation and I deleted because it wasn't being used. I'm going to assume that they're all just Sign 16s, Sign 16 arrays. And that's why they existed. M2C must write globals and then run into the M2C errors later on. Hey, don't fluff the pillows. Good to have you back. It's been a while. And like I said, it's going to happen up here somewhere. I don't know exactly where. There is going to be a condition, probably this one here. Let's do this. Let's assume that it's related to that condition. We'll set it one way here, and we'll set it differently inside that condition. That looks similar to what was in the PSP. Oh, no problem. I do that from time to time, end the stream. Thanks for coming back, though. Oops. Terrible looking. I assume that this was Sign 16s, so I'm gonna base this on that. Actually, no, they must be Sign 32s. Everything is aligned on 4-byte boundaries, so we're gonna update those. And it probably doesn't matter if they're signed or unsigned because they're passed to the coprocessor that just cares about the bits. It doesn't care about how we interpret them. All right, so that cleaned up a bunch of that stuff. There's still some stuff missing. Oh, I don't have these macros, so let's go grab those macros. I need all the macros. Well, anyway, so I was writing this 128-bit compare and swap for it needed to work on any x86-64. It actually wasn't too bad, but I always had some concerns about it. Because writing inline assembly is not something I did too often. Do we have any JLs in here? This one too. And I'm not sure if I ever... Basically, it was an arena allocator that had heavy contention. And so I wanted the ability to manage a free list with compare and swap operations. So we're missing a couple of them. We might have a slightly different version of these macros being used. Yes. Oh, yes. There is like a composite or aggregate version of this one. And the way that it's defined for the PSP is just to do 0, 1, 2. But the way that it is written for the PlayStation, I think, is this LDV3 Pro. Which is functionally equivalent, but just the implementation is a little... It's not quite the same. And it expands the same thing on the PSP. Not sure if I have to make these references or not. We'll have to check that. And I wrote all kinds of awful symbols all throughout this. That looks better. These are interesting, and I don't think I've verified this with any of the SDKs that I've found. But there's a bunch of these macros, these inline assembly macros, that do not correspond to anything that would be like an actual instruction. They don't, last I checked, they didn't correspond to the headers provided by Sony either. And so the best that we've done is to basically write them as just a word. We can try writing it and see if we can get it correct, but it doesn't seem, this value that's being passed to the C2 instruction doesn't match what's in the documentation, which is also a little strange. These get expanded when we dump the context to nothing. That's how all of the macros work. Any function macro. A few more. Looks like there's a bad argument there. It's okay. Figure it out eventually. Missing one. And what are the arcs? E is 14. Oh, maybe we must just not have STS XY. So it looks like there's ordering. So it's getting written to S7, which may be something else. So we'll figure that out in a little bit. So this seems wrong, but we'll leave it like that for now. That's fine. It'll be figured out at another point. Let's see how close this is on the PSP. Not close at all. Wonderful. That's because I have the wrong preset. Good problem to have. One error. Okay, 46%. Also not great, but not the end of the world either. So we're probably going to have some ordering things, and we have the general structure, which I think will get us mostly there. So way too many variables, so that's going to affect the stack, and we're going to get a bunch of these things where we're loading things from the stack pointer. There's usually ordering with how these get set. Do I know what the last song was? Yeah. All of these are part of YouTube Music's free stuff. It's called Peaceful Journey Path. Is this real or am I dreaming? Cue that up again. Is this the song you meant? Hey, Wumpty Dump Dump Center. Definitely some type issues here. Yeah, Peaceful Journey Path. That is the artist. Is this real or am I dreaming? Flags, I would imagine, would be somewhere else. Flags. Let's give this the right function signature. Prim index. Yeah, okay, that looks better. So I'm going to tighten up these assignments. That should get rid of a bunch of the casts and other things that are going on there. It does look... So this might be a quad. We'll put this near the end. That might be part of the for loop. Not sure. But when I'm done here, we'll look at all the offsets and see if those are correct or not. They don't look correct. Looks can be deceiving. So offset 0, offset 1. 2 and 3, that looks better. It makes more sense. This does look like it might be part of the for loop then. You ever put multiple post conditions in your for loops? I don't think I ever have. Okay, some ordering issues here. Oh, that's actually, there are no ordering issues. I always forget. Primitive is a slightly different structure on the PSP, so I always have to remember to add an additional 32 bits of padding to get all of those to line up. Well, it's true of fake prim as well. I did the wrong structure. So this looks like it's going to be a minus equals, and then probably a read again. I'm going to change this to a, there's the two different things that you'll see depending on the type of something that's less than word size. So 16-bit and 8-bit values when they're reading from a 32-bit register. You're either going to see a mask like this for unsigned values, or you're going to see SEH like this for sign extend. This is specifically on Allegrex and the MetroWorks compiler. GCC does something slightly different. It'll do shifts for signed values and still do masks, but not always for unsigned values. So the fact that SEH is being used tells us that this was originally signed. Like I said, I think that this is going to be a minus equals. It's part of an entity extension, which I've yet to define. And so we'll do a second read. I don't know for sure that that's what's being done. It looks like this is a check for not equal to 0, and that was optimized by GCC to just be a check against the top bit, which would tell you if it's negative or not. Which is kind of clever. And again, we do the same thing here. Is it most likely unsigned? So we get unsigned instructions here. There's no unsigned instruction, and we have a sign extension. So we probably want that. And the cast to a sign 16 is kind of a telltale sign as well. And this looks like it's an increment. This looks like it's the mask here being only 12 bits is kind of interesting. That suggests that it's a real mask. I think I'm gonna have to call it a day soon. But we're making some progress here. We do have a... This was a plus equals, I think. Control T doesn't work? Oh, it worked. What was happening? So the AND is interesting. It looks like this is being done first, and then there's a AND equals. Okay. Let's get through this case, and then I'll sign off, and we'll come back tomorrow. This is our typical timer construct, and these are usually, I should have done a minus minus. Usually it's a not minus minus, and then the timer. It's telling us to increment the step after the timer is done. My guess is, based on some of the instructions here, and it's not foolproof, but my guess is that this is the casket spinning. Can't be certain. the hardest thing here was those GTE macros. That's something that isn't used often, and so can be something that if you're working on this you might not be familiar with. So this is interesting. So it's signed. There we go. Thought I was screwing something else up. The rotation macro is not here, so I need to go grab that. See what other things I grabbed in this context. The scratch pad stuff, I need that. And rotation. Need to at some point I need to update my context to have the correct versions of these. Having those macros in place is nice because then I can deal with all the scratch pad stuff on the PSP side, and it should just translate right over, and it'll be a little easier to do on the PSP side. So we're up to almost 70%, which is good. We're not going to do the debug logic that'll come in. I'll copy that over. So it looks like there's some additional stuff missing. We'll figure out what that is. And then really just this last bottom part, working through that. So let's see what this looks like on the PlayStation now. So we were at 80%. I'm guessing we'll be higher. Not much, 82. Do all that nice work to clean everything up. It looks very nice. And GCC says, I don't care. I'm just gonna make a mess. It's gonna be a fast mess, but I'm gonna make a mess. Let's clean up some variables. Most of them gone, it looks like. We should be able to get to the other ones tomorrow. All right, so we've been working on what I think is the caskets. I don't know yet. Like I said, I'm working on getting a save checkpoint, and so we can try to find some of these things. But we're working on Symphony of the Night. You can go to soten.z.dev to learn more about the Symphony of the Night decompilation project. That's all I got for you. Adios.